Alrighty, let's look at this system of equations that they want us to solve algebraically. Algebraically means we could use either the substitution method, where we make the equation x equals or y equals, or we can solve it by the elimination method when we eliminate a variable. Here it would not be easy to use the substitution method because we cannot easily get an equation to be x equals or y equals since the coefficients are not 1. But we can easily use the elimination method. So I'm going to multiply the top equation by 4, the bottom equation by 2, and I'll make one of them negative. Usually I like to make the bottom one negative. All I did was I just did this like crisscrossy thing where I multiplied the top equation by the bottom equation's coefficient, and then I multiplied the bottom equation by the top equation's coefficient. So let's do that now. 4 times 2x is 8x. 4 times 3y is 12y. And 4 times negative 11 is negative 44. Now I'm going to do negative 2 times 4x is negative 8x. Negative 2 times negative 7y is positive 14y. And negative 2 times 43 is negative 86. And now let me add these together. 8x plus negative 8x is 0. 12y plus 14y is 26y, and then negative 44 plus negative 86 is negative 130. To get rid of the 26, we could divide, and we get y equals negative 5. Now we have to get the x. So I will use just the top equation, just because I like to, and I'm going to write 2. I don't know what x is, so I'll leave it as x plus 3. Instead of y, I'm going to put negative 5 equals negative 11. So then I'll have 2x. 3 times negative 5 is negative 15 equals negative 11. I will add 15 to both sides. That will get me 2x equals 4. Divide both sides by 2. And I get x equals 2. I want to check with the bottom equation to make sure this is correct. So 4, instead of x, I'll put 2. Minus 7, instead of y, I'll put negative 5. And it does equal 43. So my final answer is 2, negative 5. Good job. Now today we are going to continue using this algebraic methods of solving of systems of equations. But we are going to be doing word problems where we first need to write the system of equations, and then interpret the solutions in the context. So let's look at steps for success. First thing we are going to want to do is establish our variables by writing the let statements. Then we are going to write two equations. Think about the two topics the problem is discussing. Sometimes we'll be talking about like the number of coins and the money, or sometimes it will talk about the attendance and the price of the tickets, things like that. Then we're going to determine which algebraic method, either substitution or elimination, we are going to use to solve. Then we will solve for one variable and plug our answer into the other equation to find the other variable. And then we will make sure that our answer answers the question. All right. Let's look into this. Guided example. It's a multiple choice question. There are 50 animals, okay? Some of the animals have 2 legs, so 2 leg, and some of them have 4 leg. All right, so we have a 2 leg and a 4 leg animal. In total, there are 172 legs. Okay, so I'll let this be my x variable and this be my y variable. Let x be my 2-legged animal, let y be my 4-legged animal. So then 2x, which is the 2 legs, plus the 4 legs equals the total amount of legs we have is 172. So let's see. We only have one equation which says that, which is answer choice 4. And let's just review what the top equation is saying. The top equation is saying is that the number of 2-legged animals plus the number of 4-legged animals equals a total of 50 animals, which was that first number we were given. We need to make sure that we make legs, since that's the first topic being discussed, legs, and legs, one equation. And the only number we have left is the 50 animals, and the 2 different animals we have are x and y. All right. Pause the video and read this question and see if you can figure it out. Try the question before we go over it. There are 8 people in an elevator. Okay, so we have 8 people. Some are adults and the rest are children. So I see the equation is using x and y, so we'll let x be adults and we'll let y be children. And I know in total there are 8 people. So the number of adults plus the number of children has to equal 8. Which the only one that says that is the answer choice 1. But let's see what else they're saying. They're saying that adults weigh 150. So we're going to need something that says 150x. And then it says children weigh 50, so we're going to need 50y equals the total of 800 pounds. So all the numbers that say pounds have to be in one equation, which it is in that answer choice that we circled. All right. Let's look at this next question. All right. This is a word problem, so let's look into it. At an amusement park, the cost for adult admission is A, and the cost for child admission is C. So we don't even have to write anything. They're already telling us what letters to use, A and C. For a group of 6, so the total group was 6, group 6, there was 2 children. So if there was 2 children and there was a whole group of 6, that means there was 4 adults. And they're saying the total cost was $325.94. Okay. Then we have a second example. For a group of 5, that included 2 children. 2 children would mean 3 adults. The cost was $256.95. All ticket prices include tax. Write and use your system to determine the total cost of each type of ticket. All right. So we're going to use this data to write down our 2 systems. All right, for the first one, we have the 2 children plus the 4 adults equals $325.94. Then the 2 children plus the 3 adults is equal to $256.95. And now we could use elimination method since 2 of the variable C already has a 2 and a 2. We just need to make one of them has a negative 2. That way it would cancel out. So we would get 2C plus 4A equals 325.94. I left the first one alone. And now for the second one, I'm just multiplying each number by a negative 1. And let's do that. 2C plus negative 2C is 0. 4 plus negative 3A is 1A. And then 325.94 plus negative 256.95. That gives me $68.99. So the adult tickets cost $68.99. Now let's try to find out how much the children tickets cost. I'll use the first equation. 2C plus 4, instead of A, I'm going to put 68.99 equals $325.94. So 2C plus 4 times 68.99 gets me $275.96 equals $325.94. Let's subtract the $275.96. And we get 2C equals $325.94 minus 275.96. We get $49.98. We're going to divide that by 2. And we get the children tickets cost $24.99. So adult tickets cost $68.99 and children tickets cost $24.99. Let's just use the second equation to make sure this makes sense. Make sure I didn't make a mistake anywhere. Looks good. And you could write a sentence. Children tickets are $24.99 and adult tickets are $68.99, which makes sense that adults are usually more than children. All right, let's look at this. Determine the cost for a group of 4 that includes 3 children. So 3 children, if there's a total of 4 people, that would be 1 adult. Well, we know that the 1 adult costs $68.99. Let's find out how much 3 children cost. 3 times the children price is $24.99. 3 times $24.99 is $74.97. And we're going to add that to $68.99. Keep typing in the wrong number by accident. Plus $74.97 gets us the group of 4 that includes 3 children would cost $143.96. A group of 4 that includes 3 children would cost $143.96 because the 3 children plus the 1 adult. I just like to double check. Okay, good. Yep. All right. That's our first word problem. Let's look at a second one. Dylan has a bank that sorts coins. A panel in the front displays the total number of coins inside as well as the total value of these coins. The panel shows 90 coins with a value of $17.55 inside of the bank. If Dylan collects only dimes and quarters, so I'll let D be dimes and Q be quarters. All right, determine the number of dimes and quarters Dylan has. All right, let's first talk about the $17.55. That talks about money. So let's think about how much our money's worth. Dimes are 0.1 dimes plus quarters is 0.25. 0.25 quarters. Good. And now the only other number we haven't used yet is the 90 coins, which means that the number of dimes plus the number of quarters equals 90. Now, we can either choose to do the substitution method or the elimination method here. The elimination method would mean that we would have to multiply the bottom equation by 0.10 and then the top equation by 1 and make one of them negative. It might be annoying to use the elimination method there because we'd be multiplying by 0.10. So instead, I'm just going to solve this equation for D equals. It would be pretty easy since there's a coefficient of 1. All I'd have to do is subtract Q, and that would leave me with the number of dimes is equal to negative Q plus 90. And then I could go to that first equation and I could plug in what I know. 0.10 dimes is negative quarters plus 90 plus 0.25 quarters equals $17.55. And let's solve. This would be negative 0.1 quarters. 0.1 times 90. No. 0.1 times 90 is 9. So plus 9 plus 0.25Q equals 17.55. Let's combine like terms. This would give me 0.15Q plus 9 equals 17.55. Let's subtract 9 from both sides. I would get 0.15Q equals 17.55 minus 9. Gets me 8.55. Divide both sides by 0.15. And I get that the number of quarters is 57. And now if I want to find the dimes, well, I know that dimes plus quarters is equal to 90. And I just found out that the number of quarters is 57. So all I got to do is take away 57 from 90. And I'll find that the number of quarters is 33. So Dylan had 33 quarters and 57 dimes. And let's just make sure this makes sense. If he has 33 quarters that are 25 cents each, plus 57 dimes that are $10, 10 cents each, does that leave him with $13.95? Ooh, did I make a mistake somewhere? I think I made a mistake somewhere. 33 quarters times by 25 cents plus 57 dimes times 0.10, that does not give me the $17.55 I need. Where is the mistake I made? 0.1 dimes I just found was... Oh, this is my mistake. It was the other way around. I wrote it the wrong way. It would be 57 quarters and 33 dimes. This is why it's very important to check. So 57 quarters at 25 cents each plus 33 dimes at 10 cents each does equal the $17.55 we need. Okay, good job. And now the second part to his question. Dylan's mom told him that she would replace each of his dimes with a quarter. So he already has 57 quarters, and now he has 10 dimes, but she's going to replace that with 10 quarters. No, he already has, how many dimes do he have? He has 33 dimes. He has right now 33 dimes that she's going to replace with 33 quarters, which means if he has 57 quarters plus the 33 quarters, he would have 90 quarters, which makes sense because it said he had a total of 93 coins. So 90 quarters are worth, let's see how much money. 90 quarters are worth $22.50. Okay. It then says, if he uses all of his coins, determine if Dylan would have enough money to save to buy a game that is $20.98 with an 8% sales tax. To find sales tax, you have to change that to a decimal. So we would do 8 divided by 100, which gets us 0.08, and we have to multiply that by the price. Let's see. 20.98 times 0.08 means the sales tax is 1.6784. Add that to the 20.98, the original price. Price is $22.66, we could say. But he only has 22.5, so he would not have enough. Dylan only has $22.05, but the game with tax is 22.66, so he would not have enough money. Good job. All right, well, let's look at this next word problem. Dana went shopping for plants to put in her garden. She bought 3 roses, so I'll put 3 roses, plus 2 daisies for $31.88. Later, she went back and bought 2 roses and 1 daisy for $18.92. And we want to find the price of 1 rose and 1 daisy. And they told us to use R and D. All right. Here, we could use the substitution method easily and solve in the second equation for D equals, or we could use the elimination method. I'll show us using the elimination method. We're going to multiply the top equation by 2 and the bottom by 3. We need to make one of them negative. I like to make the bottom one negative. 2 times 3R is 6R. 2 times 2D is 4D. And 2 times 31.88 is 63.76. Then negative 3 times 2R is negative 6R. Negative 3 times 1D is negative 3D. And negative 3 times 18.92 is negative 56.76. All right. 6R plus negative 6R cancels out. 4D plus negative 3D is 1D equals 63.76 minus 56.76 gets us 7. So she would have 7 daisies. No, the daisy would cost. Daisies cost $7. And roses cost... Alright, let's solve for roses. I'll just plug into the first equation. 3r plus 2d is 7 equals 31.88. So then I would get 3r plus 14 equals 31.88. Subtract 14 on both sides. I would get 3r is equal to 31.88 minus 14. Means we have left over 1788. Divide by 3. We get that the roses are 5.96. And let's see if this makes sense using the second equation. 2 times the roses are 5.96 plus the 1 daisy is 7. Does that equal 1892? It does. Let's look at this long response question. If Dana had waited until the plants were on sale, she would have paid $4.05 for roses, and daisies are $6.50. Determine the total amount of money she would have saved. All right. So right now, in the beginning, she bought 3 roses and 2 daisies, and then she bought 2 roses and 1 daisies. So in total, she bought 5 roses and 3 daisies. Okay. If the 5 roses were $4.50 each, and the 3 daisies were $6.50 each, let's see how much money that was. The 5 roses for $4.50 each, plus the 3 daisies for $6.50. That would mean that with this new price, she would spend... I typed something in wrong. She would spend $42. Right now, let's see how much she spent. First, she spent $31.88 plus her $18.92. Right now, she spent $31.88 plus $18.96 gives us $50.84. So, determine the total amount of money she would save. Let's subtract that from the 42. She would save $8.84 by waiting for the sale. Beautiful. And that wraps up our equations on word problems with systems of equations.